board, and then I'm going to minimize my control panel. Can you read, hold on a second, just a second. Let me make sure you can read what I'm writing. This is the way this thing works, is that whatever I write, you should be able to see. What number did I just write?
7.
Okay, perfect. So that's the way it works. I can, whatever I write, I ask the student usually to bring the problems to the table. So if you have some problems that you can verbalize, I can write them out. In other words, let's say you have a problem that says the sine of 30 degrees equals what? What is the sine of 30 degrees?
I have no clue.
Okay, so you haven't started trig yet? You're still in PreCalc?
Yeah, no. I'm an algebra 2 trig.
Okay, but you haven't gotten to the trig part yet, apparently.
No, trig is second semester.
Okay, cool. Do you have some PreCalc problems that you would be able to verbalize?
I don't have any pre-calc problems.
Do you have problems? Okay, there's two ways for us to get the problems to talk about. One is you can verbalize them. Some problems are difficult to verbalize because they're graphs and they're asking you questions about graphs. Okay? Those kind of problems, what you want to do is take a picture of it, send it to my email address, and then I will bring up that picture on our common screen here so that we can both see it and we can attack that problem.
Okay.
Okay? So if you want to work through that tonight, if you have some review material that's on paper, best thing you can do is take a picture of it with your smartphone and send it to my email address. I'll bring it up, then we can talk about it. If there are any problems on there where you can verbalize it, it actually works a little bit better if you can verbalize it. In other words, maybe you have a problem that is like this. Have you gotten into cubics yet?
I mean, it looks familiar, but I feel like a lot of math problems look a lot alike, so.
Okay. Well, since I have not been in your classroom and I don't know where you're at, I need you to tell me that. In other words, PreCalc and trig are big subjects. And I wouldn't really know where to start if I didn't have any information from you. So the best way to do this is if you can find some problems that you're not quite sure of how to do and be able to verbalize it.
Okay. So I think we're doing function kind of things right now.
Okay, that's fine.
Quadratic functions.
Okay, cool.
The first one I see here is fx equals x cubed plus x squared plus 4.
All right. First of all, let's talk about terminology. That is called f of x. It's not f times x. What it means is it's a function. The only variable you're going to find on the other side of the equal sign is x. It's not a function of t. It's not a function of r. It's a function of x. Okay? So if I were to graph this, it would be a parabola like that. In other words, it is the same parabola as f of x equals x squared, only it's been vertically shifted up by 4 units. You with me?
Kinda.
You had transformation.
Okay.
What I want to do with you, Maddie, is start at the beginning.
Yes.
In other words, if you don't understand what I'm talking about here, let's go further back.
Yeah.
If I don't really care where we start, I want to start where you need to start. If you don't know what I mean by transformations, then we need to start at the beginning of transformation.
Yeah, because I have no idea what that means.
Okay, we can do that. I can do it rather easily. Is that what you're doing? Do you recognize what I mean by? I know you've missed some school, so I
Yeah.
understand a little bit what's going on, but I don't want to start at transformations if we can start at something earlier than that you don't understand. I can do transformations pretty well with you. I can give you a lot of help on transformation.
Well, yeah, let's start there then.
Okay. So where we begin on transformations is with the parent function. The function you just gave me, that's the parent function right there. Okay? What's important is that you understand what the graph of the parent function looks like. That function looks just like that. It's called a parabola. Okay?
Yeah.
If at any point you don't understand, please stop me. We'll back up.
Okay.
Okay? So, if there are 6 things you can do to the parent function. There's 3 horizontal things you can do, and there's 3 vertical things. So let's talk about vertical stuff. If I stick a negative sign in front of the function, like that, you with me?
Yeah.
What does it do to the graph?
Inverts it.
Reflects it over which axis?
The Y.
Actually, it's the x. It is a
Okay.
vertical reflection. Let's go ahead and draw it. In other words, that would be that. Whoops. Make sure.
Oh, yeah, that's what I was thinking
All
about.
right.
Okay.
That is a vertical reflection. Notice how I get the blue line. I take the red line and I flop it over the x-axis, right?
Yeah.
That's a vertical reflection, as opposed to a horizontal reflection, where I take that red line and I rotate it about the y-axis. That would be horizontal reflection. We'll talk about that in a moment. The most important thing to understand about transformations is there are 3 vertical and 3 horizontal. And that's the way to memorize them, because it's much easier to memorize them like that. Okay?
Yeah.
I've just showed you the first vertical transformation. It's a vertical reflection. Now I'm going to show you a vertical shift. Notice what I did? What is
Yeah.
that's x squared plus 2, correct?
Mm-hmm.
Well, what does that look like? It's our original red parabola moved up by 2 units. Like that. You with me? I've taken the reflection away because I want to do these one at a time.
Okay.
That's the way to understand it. One at a time, not in combination. We'll talk about them in combination later, but let's start with one at a time. There's only one other kind of transformation I can do, and that's a vertical stretch. Let's say I want to do this. Well, what does that equal to algebraically?
I don't know.
Well, if f of x is x squared, what do you think 3f of x is?
f of x cubed.
No, it's 3 times what f of x is. F of x was x squared.
Oh, okay.
Okay, it's that straightforward.
Okay.
Now, how do we graph that? Well, that's called a vertical stretch. Every point that's on this curve here is going to be 3 times further away from the x-axis. The effect of that is to vertically stretch it, like that. Notice how that blue line compares with my original red line. It's skinnier. You should have even drawn it more like that, okay? That's what happens when you vertically stretch a function, is it becomes more narrow. If I were to say 1/2 f of x, well, that would be 1/2 x squared, right? And that would actually flatten it. It would give me something like that. Those are the only 3 vertical transformations you can make. You can reflect it, you can shift it, which does not change its shape, or you can stretch it, which does change its shape. With me?
Yeah.
Okay, let's go through the 3 horizontal ones you can make. That's all there are. There's 3 vertical, there's 3 horizontal. Hold on 1 second. Let me do one thing here. Hopefully I solve my problem. Okay, so back to red. Our original function was f of x equals x squared. This time we're going to talk about the horizontal reflections we can make. Remember our vertical reflection. Everything we did was outside the function, correct?
Yeah.
On horizontal transformation, everything we do is going to be inside the function. Like that. And that's the way to distinguish between vertical and horizontal. Vertical transformations are always outside the function. Horizontal transformations are inside the function. So what would this be in terms of our function? What is f of minus x?
I don't know.
Well, what you do whenever you have a function and they put something inside the parentheses different from x, what you do is you substitute whatever is in the parentheses for x. Now that's what's in the parentheses. Substituting it for x, what do I get? What's minus x quantity squared?
Negative x.
What's minus x times minus x?
Positive x?
Yeah, positive x squared. In other words, it does not change the function in this particular case. So if this looks like this, this also looks exactly like that. Because what have I done? I have reflected it over the y-axis. Do you see why the function doesn't change at all when I reflect it over the y-axis?
Yeah.
Okay, let's just cover the other 2 horizontal reflection or horizontal transformations. Every time you look at something inside the function, it's a horizontal transformation. Notice why this is inside the function. You see?
Yeah.
Okay. If I were to graph that, I get the same exact shape, merely transformed or translated by 2 units to the right. No change in shape, only horizontally shifted. With me?
Yeah.
The last one is if it's inside the function and it has a number in front of it like that, well, what is that algebraically? What do you do when you see something in the parentheses that's not x?
Multiply it.
You plug it in for x. You don't multiply it. This is not f times 3 of x. In other words, 3 of x is not x, right? So what I do is I go up into that function, and wherever I find x, I plug in 3x. Like that. You with me?
Yeah.
Okay. Well, that's equal to 9x squared. And if I graph that, I get what is called a horizontal squeeze. Makes the graph go like that. Notice that it is similar to a vertical stretch.
Yeah.
And the fact that it makes that parabola skinnier. That's it. I've just covered all of the possible translations you can have. There are 3 vertical, there are 3 horizontal. That's it. Can't do anything else to a function.
Okay.
Are you hearing that background noise? Sounds like an ocean.
Not really.
Okay, good. I won't worry about it. Every now and then there's bad audio, and it works better if I'm on the phone. But if you're not hearing that, I will not worry about it. Okay? So, I want to test you. The way I do tutoring is I tell you how it works, and then I ask you to tell me back. So here's our parent function. First of all, tell me what that is. Is that inside or outside the function?
Outside.
Does that make it vertical or horizontal?
Vertical.
Okay. What does that translate into algebraically?
Replacing the x or.
No, the x is already, in other words, I'm talking f of x, but the negative sign is outside the function. So all I need to do is write a negative sign and then write the function.
Oh, okay. Yeah.
Okay? But the key thing for you to remember is that's vertical. Tell me what this is. Vertical or horizontal?
That is horizontal. No, vertical.
Is it inside or outside the function?
That's outside.
Correct. So this would be what, algebraically?
So that's where you put
what?
You put in what you did.
Well, no, we're not substituting here. What we're going to do is write f of x plus 3. What is f of x? X squared plus 3. That's what it is.
Okay.
What's key for you to keep in mind is that whether it's inside or outside the function, that's the big thing. Okay?
Okay.
What is this? Inside or outside the function?
Outside.
Is that vertical or horizontal?
Horizontal.
No. Outside the function is vertical, inside is horizontal.
Oh, okay.
All of these are vertical. That was outside the function, that was outside the function, this is outside. So what does this equal? If f of x is x squared, what is 3 f of x?
I really don't know.
What's f of x? Look at the top. What's f of x equal to?
X squared.
So what's 3 f of x?
3 squared.
3x squared. 3 times f of x. F of x is x squared, so 3 f of x is 3x. All 3 of those that I just did are all outside the function. Okay? Okay, let's talk about horizontal. Remember, there's 3 vertical and 3 horizontal. Here's our function. Looks like this. Okay? Now let's talk about horizontal transformation. Is that inside or outside the function?
Inside.
Does that make it horizontal or vertical?
Horizontal.
Okay. What is the algebraic expression of it? This is the horizontals, are where you take what's inside the parentheses and substitute it for x.
Wouldn't it just be x squared too?
Well, it's minus x in parentheses. And the parentheses are important. Notice the difference between the vertical and the horizontal here. The horizontal, you end up with x squared. Minus x times minus x is x squared. And that graph is exactly the same.
Yeah.
In other words, when you do a horizontal reflection of a parabola, you get the same thing you started with. Okay, now let's do a horizontal shift. First of all, is that vertical or horizontal?
Horizontal.
Why?
Because it's inside the function.
Okay, and what does that translate to algebraically? In other words, before I graph it, I want you to tell me what it is as a function. If f of x is x squared, what is f of x minus 3?
I don't know.
Whenever you have something inside the parentheses that is not x, you substitute it for x. It's as simple as that. No matter what it is. If it was x plus 1, I would substitute x plus 1 for that. If it's x squared, I would substitute x squared for that. In this case, it's x minus 3. So here's where I'm substituting. Wherever I find x, I'm going to write x minus 3. You with me?
Yeah.
Okay, so I'm going to write x minus 3 instead of x. It's still squared, so it's like that. Now, we know this is horizontal, right?
Mm-hmm.
Turns out that this is a horizontal shift, and it's to the right. That's just something you have to memorize. That if it's a minus, it's to the right by 3 units. So if I were to graph this one, based on that, I would take the exact same shape, and I would shift it to the right by 3 units. With me?
Yeah.
Okay. Notice that that is a horizontal shift. Not up or down, it's left or right. There's only one other translation that we have not covered, and that is a horizontal squeeze. Is that vertical or horizontal?
Horizontal.
Why?
With in with the function?
Because it's inside the function. That's how you tell the difference between horizontal and vertical. If it's inside, it's horizontal. If it's outside, it's vertical. So what is the algebraic expression of it?
Is it 2x in parentheses squared?
Perfect. That's all you do. It never changes. Whatever is inside the parentheses, you substitute for x. Well, what is that answer? What is 2x quantity squared?
4x squared?
Yeah. And the effect that that has on your graph, if I start there, this is a horizontal compression. In other words, it's like I put pressure right there on both sides, and I squeeze it. What do I end up with? Something that looks like that. So you can kind of see that a horizontal compression has the same effect as a vertical stretch. And that's something important to realize. They are the same thing. It's just if I look at that function, that's a vertical stretch by a factor of 4. Whereas if I look at this, that's a horizontal compression by a factor of 2. It's a little complicated, but in order to understand it, the best way to understand it is understand there's 3 vertical, 3 horizontal. All verticals are outside the function. All horizontals are inside the function. And there's one last extremely important thing. Do your reflections first. Doesn't matter how you do the other, but do your reflections first. I'm going to give you an example. Here's our parent function. There's like 10 elementary functions that you should know, and you should know what they look like on a graph. X squared is one of them. Square root of x is another one. Just x is another one. X cubed is another one. Sine x is another one. Log x is another one. All of those are parent functions, where if you apply a translation to a parent function, you get a more complicated function. So here's the kind of question you're going to be asked. What does that do? First of all, tell me if that's inside or outside the function.
Outside.
Correct. I'm going to call it g of x because it's no longer f of x. So we'll call it g of x. What does that do? That makes it what? Vertical or horizontal?
Horizontal.
Nope.
No, sorry. Vertical.
Okay. So if the original function looks like this, what is this function going to look like? If it's a vertical translation, what does it look like?
Is it going to shift?
Yep. Which way?
Up 3.
Perfect. That's what that function looks like. Same exact shape. Shifts do not change the shape. Stretches or compressions do, but shifts do not, nor do reflections. Okay? So what if I said 8th of x equals minus x squared? Is that inside or outside the function?
Outside.
Meaning it's vertical or horizontal?
Horizontal.
Nope. Got to get that right. You got to get inside is horizontal, outside is vertical.
Yeah.
Always. Memorize that.
Yeah, yeah.
So this is outside the function. In other words, this is what it really is. It's minus f of x, right?
Yeah.
Okay, that's outside. What kind of a reflection is that? Negative signs are always reflection.
Well, I know it's like gonna just be the original one, but like flipped upside down.
Yeah, exactly. That's called reflected over the x-axis.
Yeah.
So it looks like that. Okay? So there's two of the verticals that you can have. Let's have one more, j of x, be equal to 2x squared. In other words, so far I'm doing these one at a time based on the original function. What effect would that have? How would that show? First of all, is that vertical or horizontal?
Vertical,
Why?
because it is outside. No.
Good.
Yeah, because
What is the effect of the two? This two. What does it do to the shape of the function? Is it the same shape or is it stretched or compressed?
Is it stretched?
Stretched. So this one would look like this. Stretched by a factor of 2. Skinnier, in other words.
Yeah.
Okay? Now, here's the kicker. Well, I won't even get into that yet. I want to keep emphasizing this so we get it so you understand the difference between vertical and horizontal and what each's effect is. Trust me, this is going to be huge. You're going to completely understand translations after. Okay?
Okay.
Still going to work with this function. Tell me what this is. I'll change it. I don't want to call it f of that because it's actually g of x minus 3 would be what? Oh, excuse me. It is correct to call that f. Hold on a second. What is f of x minus 3? If f of x is x squared, what is f of x minus 3?
Is it in parentheses x minus 3 squared?
Perfect. What kind of translation is that? Is it horizontal or vertical?
That is horizontal.
Is it a shift or a stretch?
I think it's a shift.
Yeah, whenever things are being added or subtracted, they're always shifts.
Yeah.
So if this function, the top one, looks like this, what does this function look like? X minus 3 quantity.
Would it be going down 3?
It's horizontal. Up and down mean vertical.
Oh, yeah, you're right. Sorry.
Horizontal means left or right.
So it'd be going left 3?
It turns out that it's right.
Oh.
If it's x minus 3, it's to the right. If it's x plus 3, it's to the left.
Oh, I was just thinking because if you go to the
It's an oddity about it, but just remember that if it's x minus 3, it's going to the right. So if it's x minus c, it's to the right. Okay? So this would be shifted, exact same function, just shifted 3 units to the right. Like that.
Okay.
Okay? How about this? First of all, is that vertical or horizontal?
That is horizontal.
Okay. What is its algebraic expression?
In parentheses, 2x squared.
Okay. And what is that called if I went to graph it?
I think that would be either, oh, I can't think of the word.
It's horizontal, right? So start with horizontal.
Yeah,
Is it a shift, a stretch, or a compression?
I think it's either a shift or compression.
It's not a
No,
shift.
not,
Remember,
not shift.
shifts are only, you only get shifts when you add or subtract. Here we're multiplying.
Yeah, that's not what I meant to say. Compression and the.
It's a compression. Oddly enough, when it's horizontal and this number is greater than 1, it's a compression. If it's vertical and that number is greater than 1, it's a stretch. But notice that a horizontal compression is the same as a vertical stretch. And as it should be, because if I finish this, it becomes 4x squared, like that. Well, if I'm looking at that alone, that's a vertical stretch by a factor of 4, right?
Yeah.
Okay. And that covers almost all of them. I ran out of room in this one. Do this. There's our original function. So only one last thing to look at. Horizontal or vertical?
Horizontal.
Because?
Inside the function.
Okay. What is the algebraic expression of that?
So it would be in parentheses, negative x squared.
Okay. What's going to be the effect on our graph? If that graph looks like this, what is this graph going to do? First of all, what is a horizontal reflection do? Reflects over which axis?
X.
Nope, that's vertical. Think of, if I were to take that shape and flop it down, that's vertical, right?
Yeah.
If I flop it left and right, that's horizontal.
Okay.
So if I were to reflect this shape, what do I get? I get the exact same shape. In other words, when you horizontally reflect this particular curve, it doesn't change anything. So for this example, I'm going to go look at a different function. In this case, we're going to look at this one. Okay?
Yeah.
That function looks like this. Okay? Now, we'll do a horizontal reflection. So first of all, what does this do algebraically?
In parentheses, minus x squared.
Cubed.
Oh.
It's a
Where does it cube?
different parent function. There's like 10 of these. Okay? X squared works good for certain translations, but it doesn't work really good for horizontal reflections because it doesn't change the curve. This one it does. If I take this curve and horizontally reflect it, it becomes this. You see?
Oh, yeah.
And if I look at this function, what is minus x cubed? Is the same as that.
Yeah.
Guess what? A horizontal reflection is the same as a vertical reflection. If I took this curve and made a vertical reflection of it, it would look exactly like that. In other words, this particular function, x cubed, does look different when you have a horizontal reflection of it. Changes its appearance. You with me?
Yeah.
So some functions do change when you do a horizontal reflection. X cubed is such a function. There's others. Let's talk about another general function that is one of the elementary functions. That looks like that. Okay? So let's talk about reflection. I put the negative sign there. Is that vertical or horizontal?
Vertical.
Okay, what's its algebraic expression?
Will it just
Put a negative sign in front of that. That's all you need to do.
oh, okay.
Like that.
Yeah.
Okay? Now I know this is vertical, right? So
Yeah.
if I want to reflect this, that means it's a reflection over the x-axis. I get that. The blue line is minus square root of x. A vertical reflection. Is that vertical or horizontal?
Horizontal.
So it's a reflection about what? Which axis?
The x-axis.
No. X means you're flopping it back and forth vertically.
Oh, okay.
This is horizontal reflection. So if I take my red line and horizontally reflect it, I get that. Right?
Okay, yeah.
I mean, you with me? I don't want to confuse you with my colors here. But that is
No,
the square root of negative x is that green line. Notice the
okay.
green line is a reflection about the y-axis. The blue line is a reflection about the x-axis. Reflections about the x-axis are vertical, reflections about the y-axis are horizontal. With me?
Yeah.
Okay, so let's take a little bit more complicated. I'm going to leave my function as the square root function. Now I'm going to give you a completely new function. What is that? What kind of transformation? I want you to define it for me vertically or verbally.
That's a horizontal function.
Is it inside or outside the function?
Because it's inside.
Is it?
Oh, it's hard to tell without parentheses.
No,
So I guess
that's outside. If it was inside, it would be the square root of x plus 2. Inside the radical sign. So this is definitely outside the function. So does that make it horizontal or vertical?
vertical.
Make it a shift or a stretch?
I think I make it a shift.
Shift. You're adding or subtracting. It's always a shift. Hold on. Something's not wrong here. Well, in other words, I take the original curve and shift it up 2 units, and I do not change its shape because it's a vertical shift, up or down. That was minus 2. We move it down 2. Okay. Again, I'm going to use the square root function. This time I'm going to do 2 things. What two things? First of all, it always starts from the left. What does that do? One last thing, Maddie, before you answer that. When you have more than one translation happening, you have to do your reflections first. Doesn't matter the order that you do anything else, but you have to do reflections first. So that negative sign is a reflection, right?
Yeah.
The vertical or horizontal?
Vertical.
Okay. So if my original function looks like this, then this function looks like I'm reflecting it vertically, right?
Yeah.
Which axis is that? I'm going to reflect it about the x or the y.
X.
Makes it look like that, correct?
Yeah.
Okay. Now I deal with that. What is that?
That's a shift.
Up or down?
Up.
By 2 units. So
Yeah.
I take this curve and I shift it up by 2 units exactly like that. Don't change its shape because shifts do not change shape. You merely move it up or down or left or right. So this would be that function, negative square root of x plus 2. I first applied my reflection, and then anything else. Once you've applied your reflections, you can do the others in any order you want. Let me give you a little bit more complicated one, just so you can understand where I'm going on this. What if I told you I have a function like this? Let me not make it quite that hard. Let's talk about that. First of all, tell me how many things are going on to this function. How many translations are there?
2 translations.
I see 3. There's 1, there's 2, there's 3.
Oh, I didn't even see that.
First of all, always look for your negative signs first, because those have to be done first. So what does this do? Vertical or horizontal?
That is vertical.
Vertical what?
Reflection.
Over what axis?
X.
Correct. So that is, and this is the kind of problems they're going to give you. They're going to give you a function, and they're going to say, what has this function had done to it from its parent function? So the first thing you have to recognize is when you see that function, that the parent function is square root of x. Okay? And the first thing we see is that it's got a vertical reflection. Let's just go left to right. Consequence of that x minus 2 inside the radical. First of all, is that horizontal or vertical?
That's horizontal.
Is it a shift or a stretch or a compression?
That's a shift.
Is it left or right?
Left.
It's to the right. Remember, it's always opposite that sign.
Okay, yeah. I remember.
So that is a horizontal shift by 2 units to the right. That's how I would describe that. Horizontal shift by 2 units right. Finally, the third thing, what is that?
That is a horizontal
Hold on.
shift.
Is it inside or outside the function?
Outside.
What does that make it?
Vertical.
Okay, always start there. In other words, first of all, figure out whether it's inside or outside the function. If it's outside, it's always vertical. If it's inside, it's always horizontal.
Okay.
What is that plus 3? What's its total description?
The vertical shift to the left.
Vertical is up or down?
Up.
Okay. Do you get that? That horizontal is always left or right, vertical is always up or down.
Oh yeah.
It's all right.
I
Okay.
was thinking.
So here I'm going to draw these as we move along. I'm going to draw the parent function. Okay?
Yeah.
That's what the parent function looks like. Secondly, I'm going to do the vertical reflection. Do vertical reflections first, always. See that?
Yeah.
Thirdly, I'm just going to take them in the order that I see them. Once I've done my reflections, I'm going to shift 2 units to the right. You with me?
Yeah.
And finally, I'm going to shift my last picture up 3 units. That's how you do it.
Okay. Yeah.
And like I said, the kind of problems they're going to give you is they're going to give you that function right there. Minus the square root of x minus 2 plus 3. And they're going to ask you what has been done to this function. What translation? And the answer is a reflection over the x-axis, followed by a horizontal shift 2 units to the right, followed by a vertical shift 3 units up. That's your answer. You could give that answer verbally, as in these words, or you could do it graphically, as in graphing each change that takes place. All right. Let me drill you a little bit, and I'm going to start with different kinds of functions. Have you had logs yet?
What?
Have you had logarithms yet?
No.
Okay. Let's take the x cubed function. And again, it's really helpful if you can memorize what these basic graphs look like of your basic elementary function. I don't know if your teacher has given you a list of these, but there's 8 to 10 of them. X being one, x squared being another, x cubed being another, square root of x being another, sine of x being another, log of x being another, so forth and so on. Okay? And
Yeah.
it's really, you need to know what these basic graphs look like. Because you can't graph the translation unless you know what the elementary graph looks like. So, what's that look like? Or tell me algebraically what that is.
Would it be in parentheses negative x cubed?
Well, first of all, is that vertical or horizontal? Always the first question you ask.
Vertical.
Does that make it inside or outside the function?
It's outside.
So is it this or is it this?
Is it the first one?
Yes. Definitely the first one. Turns out that both of these are the same, but that's neither here nor there. Fact is that negative sign is outside the f of x, so it's negative x cubed. In other words, we take whatever f of x is, and we put a minus sign. Now, how would I graph that?
Would you just take like the one that you already have and like basically like flip it like the other way?
Describe it better than that. Flipping
Like
it the other way does not describe it.
Yeah, sorry. It's like
Reflecting about which axis?
reflect it on the y-axis.
Nope, that's horizontal.
On the x-axis.
Yeah, let me see if I can, I can't show you my hand here, but here, and let me go back to this function, which shows this a little bit better. Square root of x. You with me?
Yeah.
This one graphs like this. What do I have to do to that to make it look like negative square root of x? It's vertical, right?
Reflected on the y-axis.
So put your hand, open face, facing your eyes, right above the x-axis, and flip it vertically below the x-axis or across the x-axis. That's what a vertical reflection is. See why I call it vertical? We're flipping it about that line right there. If I flip that about that line, I get that. Right? You see why that is a vertical reflection and not a horizontal?
Yeah.
Just because the x-axis is the horizontal axis doesn't mean that a vertical reflection goes about the y-axis. It doesn't. It goes about the x-axis. So if I want to graph negative square root of x, I have to flip it about the x-axis. It makes it look like that. That is a vertical reflection. This is what it started at. Okay. Maddie, did you want to go? Your mom paid for 1 hour, and I do give a half hour for free. But sometimes an hour and a half is a little much.
Yeah.
So you may not want to do a full hour and a half today. If we quit now, you have a free credit for a half hour in the future. Or we can go for another half hour, and I will let you choose. I don't know what state your brain is in at this point. A lot of people, their brain gets kind of fried after you're doing an hour of math that is new, and it doesn't really do any good to keep going. I will let you make that decision, or you and your mom, if you want to talk to her or whatever. But
it's better for me if I just sit and like let what I already.
Okay. Okay. I think we've covered translations pretty good. Just remember there's only 6 of them. There's 3 vertical and 3 horizontal. And the way to memorize them is that way. Don't try to memorize all 6 of them randomly. That's much harder to do. If I wanted you to memorize a 6-digit number, I would give it to you in 2 batches of 3 digits each. Right? That's why we give phone numbers. We don't give a phone number as a 7-digit number. We give it as a 3-digit number, dash, and 4 digits. In other words, when you're trying to memorize stuff, you want to break it up into small packets.
Yeah.
And 3 vertical and 3 horizontal is much easier than 6 translations. So that's why it's really, really important that you recognize, first of all, whether it's vertical or horizontal. That's totally based on whether it's inside or outside the function. And that
Yeah.
whittles it down a little bit easier for you to memorize. But you got to memorize. There's no other way to do it.
Yeah.
All right. Let's end there and let your mom know that you do have a half-hour credit coming. And that's how it works online. Okay.
Okay.
Also, I do record this and I make it available to you by the next morning. So I will send whatever email you listed. Here, let me just bring it up, make sure that that's the right one. ShellyFrosty@AOL.com.
Yeah, that's great.
I will send a link to that email address that shows you how to watch the recordings of every session we have.
Okay.
It's just a YouTube channel where I put all of my recordings. You can always go there and it'll have your initials and it'll have the date. So you can always watch. This would be like watching an hour YouTube. Only the advantage is you can fast forward, you can reverse, you can pause. So if you want to review the 6 rules, you can do it on your own without me. Okay, so these recordings can be helpful to you. And I will send a link by tomorrow morning as to how to watch these. And it's the same link each time. You just have to look for the correct name on the file. Your files will all say MM, like today's file would say MM111219. Your initials along with the date, and then you'd be able to play this recording at your leisure and at whatever speed you want.
Okay.
Okay? Maddie, it was nice to meet you. You live in Peyton?
Yeah.
I did a seminar at Falcon High School earlier this year on taking the SAT.
Oh, yeah.
A one-day, 6-hour seminar on a Saturday. Yeah, that's a beautiful high school. You don't go to Falcon High School, though, right?
I go to LP.
Yeah. Okay. But no, Peyton's a beautiful place. The trip getting there was gorgeous. I've never driven through the Black Forest like that.
Oh, yeah, that's I drive to school every day.
Gorgeous. I couldn't believe it. So anyway, Maddie, good luck. I hope to work with you in the future. Your mom knows how to go to my website, schedule online sessions. The next time, if you have another online session, the only thing I will do is text you the meeting ID number, which changes with every session.
Okay.
Okay? I won't call you because you have the icon here. If you're still looking at my screen, see this orange icon I'm pointing to?
Yeah.
Looks like a flower, kind of?
Yeah, I have it on my dash.
You have it. Okay, so the next time we have a session, just double click that and put in the meeting ID number that I text you. Next thing you know, we'll be in a session.
Okay.
So I don't need to initiate it by a phone call. I will just text you the meeting ID number.
Okay.
Okay? And in order to close out GoToMeetings, all you need to do is click on the X. First of all, expand that control panel, and then click on the X, and that will close you out of the GoToMeetings.
Okay.
All right? Maddie, it was nice meeting you. Hope to work with you again.
Yeah.
Bye-bye.
Bye. Thank you.
Mm-hmm.